Hello guys, good evening. Quick check, are you able to hear me? Is the audio clear? Are you able to see me? If one of you can kind of post it in the chat window, I'll switch to the chat window and check out whether I'm getting an S from you guys. I'm going to say, am I audible? Are you able to see me? A response from one of you will help us get started. Okay, you're able to hear me? Super, super. Let's get started. Let's start the session, roll it out. In today's session, what we're going to be doing is we're going to be looking at 4 interesting questions. I want to classify them, give a wrapper around these kinds of sessions. It could be for verbal, it could be for quant. Today, we are focusing on quant. We are looking at 4 what I would call as must-solve questions. These must-solve questions are typically the kind of questions which you would see when you get a Q49, Q50 level of difficulty. That's a level of question that we'll be discussing. And these questions help us learn a lot as we solve them. It's not just getting the answer to the question right. It is also about what are the other things that we learn as a byproduct that can be applied to more than one such question. For example, some question, what you learn is applicable only to that question. But some other questions could set the tone as a framework. The questions that we select for these must solve usually are the ones which would at least lend themselves to becoming these framework questions, right? Without spending any more time, the 4 questions we're going to be talking about come from a wide range of topics. 2 of these are problem solving, 2 of these are data sufficiency question. Let's get started with the first of the problem solving question. I'm going to share the screen. Just give me a minute before I do that. What better way to kickstart this? We'll start with a permutation combination question. I would classify this question as a 700 level question, quite an interesting one. How many 4-digit positive integers exist that contain the block 25 and are divisible by 75? Right? There are too many things said here. And they've given us one good clue. They've said what these numbers are. A number such as 2250, a number such as 2025 are examples of such numbers. You see this 25 as a block in this number. It could be the second and third digit. It could be the third and fourth digit. It could be a number which is of the form 25xx. So we need to find out how many 4-digit numbers exist that contain the block 25 and are divisible by 75. Let's get started. What would be the test of divisibility for 75? Any number that is divisible by 75 will satisfy both these conditions. The number will be divisible by 25, 1, and second, the number will be divisible by 3. Let's spend a minute on understanding what would we mean by a number divisible by 25. Any number that is divisible by 25, it could be a 2-digit number, it could be a 3-digit number, it could be any number of digits that it has got. The last 2 digits, the rightmost digits, there are so many digits here, the rightmost digit, last 2 digits should be divisible by 25. So what does that leave us with? The last 2 digits can be one of these 4 options. It could be a 00, it could be a 25, it could be a 50, or finally it could be a 75. If the last 2 digits, the tens and units place taken together, are one of these 4 options, then the number is divisible by 25. So we now have understood what is this test of divisibility by 25. Test of divisibility by 3. I'm not sure whether we're actually going to be using the test of divisibility for 3 in this question. We'll do it a little differently. But having said that, test of divisibility by 3 is basically simple. Add the sum of the digits. In this case, let's do for this number 2025. 2025, sum of the digits is 2 plus 2, 4. 4 plus 5 equals 9. So sum of the digits is divisible by 3. The number is divisible by 3. We are not going to be using that. We'll be using a slightly different approach to solve this question. But let's get started with this. Well, let's see what are all the possible cases. This number 25. There's one possibility is that 25xx is a possibility. 25 appears as one block. And then the last 2 digits, we'll have to fill it in different ways. At the face of it, it looks like you're going to be having 99 such cases because the last 2 digits can start with a 00 and can go all the way up to 99. Actually, 100 such cases, not 99. So how do we decode from this? Let's start with this. The last two digits cannot be, let's say, a 0, 1, and the number can never be divisible by 25. So it basically whittles down from these 100 to just 4 possibilities. We have a 2525, we have a 2550, we have a 2500, and we have a 2575. Let us check out how many of these 4 numbers are divisible by 3. 2525, 7 plus 7, 14. 14 is not divisible by 3, so this number does not work. 2550, 2 plus 5 is 7, 7 plus 5 is 12. 12 is divisible by 3, so 2550 is divisible by 3 and is divisible by 25, so is divisible by 75. 2500, sum of digits is divisible, is not divisible by 3 because the sum of the digits is 7, so this will not work. Lastly, 2575, 2 plus 5 is 7, 7 plus 7 is 14, 14 plus 5 is 19, 19 is not divisible by 3, so it's not divisible by 75. So in the 25XX form, if the 25 as a block starts this 4-digit number, we have only one such option. Let's move on to the second possibility. Let's move with a 0, 2, 5 and a dash, not a 0, a dash 2, 5 dash. This 25 as a block appears in the second and third place, the hundreds and the tens place. Let's check out what all possibilities we have. We'll start with the test divisibility by 25. That's the first thing that will help us zero in on the numbers. What all possibilities do we have with the tens digit being a 5? The only possibility is the unit digit being a 0. So the tens digit is a 5. A dash 250 is the only possibility we have. With a dash 250, the number is definitely divisible by 25. We have taken care of that. Now we need to plug in values for the thousands place such that the sum of these numbers is divisible by 3. As it stands right now, a 2 plus 5 plus 0 is equal to a 7. This number is of the form 3k plus 1. It's essentially a multiple of 3 plus and 1 added to it. So if you want to make this entire thing to be divisible by 3, to a number which is of the form 3k plus 1, add a 2 to it initially. So a 2250 will make it work. So 3k plus 1 plus 2 will work. Any number right now you found out this number is divisible by 3. If you add a 3 to this number, definitely the resultant number will be divisible by 3. For example, a 2253 will be divisible by 3, but that is not divisible by 25. What are we trying to fill? We are trying to fill the thousands place. So what I'm going to do is, I'm not going to bother about whether 3 will work or 4 will work. I'm going to add a 3 more to this. So a 5250 will be divisible by 3. Because if a 2250 worked, then we are adding a 3 more to it. So 5 plus 2 is 7, 7 plus 5 is 12. This number is certainly divisible by 3. And we started by this number being divisible by 25. So this is going to work. The next thing, I'm going to add a 3 more to this 5. That will make it as 8250. If you add a 3 more to it, it's going to go back to 11, which will not be a 4-digit number. So how many numbers exist which are of the form dash 25 dash, in the sense that the 25 appears in the second and third place? We have 3 such numbers existing. So we have 1 which is of the form 25xx, if I can call it. There are 3 of the form x25x form. Then there's a third possibility where the 25 appears in the last 2. We started at the first 2, middle 2, and it's in the last 2. This number is certainly divisible by 25, so no sweat there at all. Now we have the first and the second digits to be filled in. How many such possibilities exist? This cannot be a 0, 0. It's not going to work. Basically, the number will not be a 4-digit number. The least value that we can think of is basically this first 2 digits can be a 1 and a 0. If it's a 1025, let's check out whether this number is divisible by 3. 1 plus 2 is a 3, 3 plus 5 is an 8, so this is not divisible by this. Let's go to the next value after 10. So I'll go with a 1125. Let's see whether this is divisible by 3. 2 plus 5 is 7, 7 plus 1 is 8, 8 plus 1 is 9. This is certainly divisible by 3. So I can start with the first 2 digits. Let's just look at these 2 gaps. What can it be? It can be 11. Now 1125 is divisible by 3. That's established. 1225 will not be because I'm adding 1 more to it. So the sum is going to be 1 plus 2 plus 2 plus 5. That won't work because this is a 9 plus 1, 10. It won't work for a 1 plus 3 plus 2 plus 5. I'm just making the first 2 digits to be a 12. It's not working. I'm making it a 13. It won't work. Let's check out for a 14. It's going to be 1 plus 4 plus 2 plus 5. Will this work? 5 plus 2 is 7. 7 plus 5 is 12. It works. Essentially, if it worked for 11, keep adding 3 more to it and a 3 more to it and a 3 more to it. It'll work. So what all numbers will work? It'll work for all numbers which start from 11 and follow an AP, because we keep adding a 3 to it. Follow an AP with a common difference of D. So A is equal to 11. First term is 11. The common difference is equal to 3. Let's check out what is the last term. So from that we can count all the terms that are there in this series. The last term, the last 2-digit number is a 99. This number is divisible by 3. So 9925 will not be divisible by 3 because 99 is divisible. 2 plus 5, 7 is not. Let's check out what happens with the preceding number. 9825. 2 plus 5 is a 7. 7 plus 8 is a 15. 15 plus 9 is a 24. This certainly is divisible by 3. So the last number in our sequence in this arithmetic progression is a 98. Now all that is left is to count how many such numbers exist. We'll use the AP formula. AP formula is an equals the first term plus n minus 1 times the common difference. We found the last term to be equal to 98 because 9825 is the last 4-digit number that has 2 5s in the last 2 places and 98 in the first 2 places, that is divisible by 75. So this 98 is the last number. This is equal to the first term in our sequence was 11 plus n minus 1 times the common difference for the first 2 digits was basically a 3. 98 minus 11 is an 87. 87 divided by 3 is the value of n minus 1. So n minus 1 equals 29 or n equals 30. So how many numbers of the form xx25 exist? We have 30 such numbers. So how many numbers totally exist? Numbers of the form 25xx, we counted 1. Numbers of the form x25x, we counted 3 of them. Numbers of the form xx25, we realize there are 30 of them. So all together we have 1 plus 3 plus 30, which is 34 such numbers exist. Quickly summarize this entire thing. It's an interesting question in a printed form. So even in cases where my handwriting was not clear, you guys will be able to follow it. Let's get started. The numbers can be of the form 25xx, x25x, xx25. These are the 3 possibilities, 4-digit numbers that contain the block 25. We need the number to be divisible by 75. So what is the test of divisibility for 75? It should be divisible by 25 and should be divisible by 3. Let's get started with the first of the scenarios where the number is of the form 25xx. The number of the form 25xx is divisible by 25 if its rightmost digits are one of these 4 possibilities, 00, 25, 50 or 75. The number will be divisible by a 75, then it is not just divisible by 25, it should also be divisible by a 3. Of these numbers 2500, 2525, 2550, 2575, the only number that is divisible by 3 is 2550. So 2550 satisfies the condition that it's divisible by 25 and divisible by 3. So how many such numbers of this 25xx format exist? One such number exists. So more to the second variant, picking numbers of the form x25x. So what could be the only possible value for the last one? We know the last 2 digits should be either 00 or 25 or 50 or 75 for the number to be divisible by 25. If the tens place is a 5, these all possibilities are ruled out. So the 4-digit number is going to be of the form x250. So what all possible values can x take? 2 plus 5 is a 7. So if I add a 2 more to it, it will be divisible by 3. If I add another 3 more to it, it's going to be divisible. If I add another 3 more to it, it will be. So if this number is a 2250, it will work. 2 plus 3, that makes it as a 5250, it will work. If it's a 5 plus 3, 8250, it will work. 8 plus 3 is 11, which will take us beyond the 4-digit numbers. So how many such possibilities exist? We have the following possibilities, 2, 5 or 8 for the thousands place. So 3 such numbers satisfy this condition. So initially we had 1 for 25xx. For x25x, we have counted 3 such possibilities. Now let's move on from here to the last one, where the numbers are of the form xx25. They're definitely divisible by 25. We just need to find out how many of these values, when I substitute xx 2-digit values, it's going to make this number being divisible by 3. The smallest value that will make it happen is basically going to go this way. This number 2 plus 5 is a 7, which is of the form 3k plus 1. We want this entire sum to be divisible by 3. So if I add another 3m plus 2 to it, if these 2 digits, let's say these are a and b, the first 2 digits, if a plus b end up giving us a value which is of the form 3m plus 2, the final sum for all 4 digits is going to be 3k plus 1 plus 3m plus 2, which is 3 times of k plus m plus 3. So this number will be divisible by 3 because 3 times of k plus m is divisible by 3. 3 is divisible by 3. So all that is left is to pick this a plus b, the values for the first and second digits, which are of the form 3m plus 2. So it should be a multiple of 3 plus 2. In the 2-digit numbers, the smallest 2-digit number is 10. This is of the form 3 into 3 plus 1, not 3m plus 2. The smallest number that will satisfy this 3m plus 2 is a 3 into 3 plus 2, which is equal to 11. So the first number of the sequence is 11. Let's quickly jump to the last number of the sequence. 33 into 3 is equal to 99. So if I went with a 32 into 3 plus 2, that is 98 is going to be the largest number that will satisfy this condition. They found out the smallest number, they found out the largest number. How many such numbers are there? 98 minus 11 by 3 plus 1. This plus 1 is because we subtracted 11 from it, whereas we should have included 11 also. So that gives us 30 such numbers. So how many numbers in total? We have one number satisfying this condition, 3 numbers satisfying this conditions, and 30 numbers satisfying the last case. So in all, 30 plus 3 plus 1, 34 such numbers exist. Lovely question. So these kinds of questions, there's no one single formula to work with them. You basically understand the two rules and then work from there and build upon it. What is the second one? We'll make a shift from PS to DS now. Number properties, absolute values, kind of a number, kind of a question. Is modulus of x greater than x? The question. For quite a few questions, get to understand, restate the question, rephrase the question, understand what the question is stating. You'll probably get a question which is much simpler than what we are looking at. The question stated, is modulus of x greater than x, right? What is modulus of x? Modulus of x gives us the magnitude of x. X, let's say, if it's a positive number, right? I'm going to take 2 as an example. Modulus of 2 is equal to 2. So if x is a positive number, modulus of x is equal to x. Is it greater than x? Obviously, the answer is no. If x equal to 0, what is modulus of 0? Modulus of 0 equals 0. So in this case also, modulus of x is equal to x. You have a question which says, is modulus of x greater than x? We'll answer this with a no. If x is a negative number, let's say x equals minus 2, modulus of minus 2 equals a 2. So modulus of minus 2 will be greater than minus 2. So modulus of x, if it is greater than x, that is going to happen only when x is a negative number. So the question can be restated. The question is asking us, is modulus of x greater than x? This can be simplified as, is x less than 0? That is what this question is all about. Sometimes investing this half a minute, 45 seconds in understanding how to restate this question can save a lot of time, right? Once you know, is x negative, a lot of these statements fall in place. Let's get started. Is x less than 0? Any DS question, before you start evaluating these statements, answer these two questions. When is the data sufficient? It's an is question, even in the reworded form. Is questions have either an yes or a no as an answer. If x is less than 0, then we'll answer the question with an S. If conversely we realize that x is greater than or equal to 0, don't forget the x equal to 0, returning a no as an answer. If we get x greater than or equal to 0, we can conclude it saying that it's a definite no. If we get a definite yes or a definite no, the data is sufficient. If for some values we say yes and some for which we say no, then the data is not sufficient. So get this clarity. What kind of an answer? When is the data sufficient? Having done this, let's dive into statement 1. It says x square plus y square equals 4. Let's just look at it. What all can happen? X square, y square. Neither of these numbers, neither x square nor y square can be negative. Neither of these numbers can be negative. They can be 0 or they can be positive. I'm looking at possibility 1. In possibility 1, I can have x square to be a 0 and y square to be a 4. Is it possible? 0 plus 4 equals a 4. So we have x square to be equal to a 0, which means x equals 0. If x equals 0, what is the answer to our question? Is x less than 0 the question? The answer to our question is a no. I'm going to look at a counter example. This could be a possibility where x square equals a 2 and y square also equals a 2. So in this case, x square is 2, or I'll even make a life like little easier. Let's make y square a 0 in this case. Let's take x square to be a 4 and y square to be a 0. So this gives us 4 plus 0 equals 4. It's a good example to go with because I don't need to work with irrational numbers. So x square equals 4 is what we get. If x square equals 4, what all values can x take? X could be a 2 or x could be a minus 2. So what's the question? Is x less than 0? If x is a 2 and therefore x square is a 4, our answer is going to be a no. If x is a minus 2 and therefore x square is a 4, our answer is going to be an S. Do we have a uniform answer? No. We get no for a couple of instances and we get yes for one instance. So we are not sure. So can we eliminate some answer choices? If statement 1 is not sufficient, eliminate answer options A and D. We are down to B, C or E. Let's summarize it in a printed form and then evaluate statement 2 alone to decide whether it is B or we need to combine the two statements. Here is it in the printed form. The question is x less than 0? We have x square plus y square equals 4. both x square and y square are non-negative. X square could be 0 or x square could be positive, as we saw with the examples. If x square is 0, then if x is 0, the answer is no. If x square is positive, x can be a positive number or a negative number. So you get a no and an yes. So sometimes no, sometimes yes. The data is not sufficient. If statement 1 alone is not sufficient, eliminate answer options A, D. We're down to B, C, or E. Let's evaluate statement 2 alone. Statement 2 alone basically is this: x cube plus y square equals 0. One thing is very clear: y square is always non-negative. I'm going to look at possibility 1 again. In possibility 1, x cube equals 0, y square equals 0, and therefore x cube plus y square equals 0. X cube plus y square equals 0. So what can we infer about x? X equals 0. What is the answer to our question? Answer to our question is a definite, is a no from this part. What else can it be? We know that y square cannot be negative. So y square was 0 is a possibility. Y square could have been a positive number. Let me take y square to be something like a plus 8. So what would x cube therefore be to make the sum a 0? X cube will have to be equal to a minus 8. I'm taking a counter example. So this number is a minus 8 plus an 8, which is equal to 0. If x cube equals minus 8, then what can be inferred about x? X equals a minus 2. Is x less than 0? We get an answer, which is yes. So for the same statement, x cube plus y square equals 0, we get a no for one example, we get an yes for another example. We're not getting a conclusive answer. So statement 2 alone is also not sufficient. At the end of evaluating statement 1, we crossed answer options A, D. We were left with B, C, or E. Now we realize statement 2 is also not sufficient. Eliminate choice B. We are down to C or E. Quickly summarize it in a printed form and then move on to combining the two statements and see what happens. Y square is always non-negative. There's a possibility that both x cube and y square are 0, in which case x is 0. Answer to the question is no. There's another possibility where x cube is negative and y square is positive, as we saw with an example of y square being 8 and x cube being minus 8. In that case, x is negative. Sometimes no, sometimes yes. Data not sufficient. Rule out choice B. We are down to C or E. Combine the two statements. What do we have? When we combine the two statements, we get x square plus y square equals a 4 and x cube plus y square equals a 0. We have if x is equal to 0, which is a possibility that we had here. We had x equals 0. Then the same thing should hold here too. From statement 1, x square is a 0, y square becomes 4 from statement 1. If x cube is a 0 here, y square should also be a 0 here, which is when statement 2 will hold good. So if x is a 0, x square and x cube will be 0. From statement 1, we get y square equals 4. From statement 2, we get y square equals 0. So we can't have two different values for y square, and you cannot combine the two statements. So x being a 0 is not a possibility. So the x being 0 is not a possibility. What is the other possibility? We can have that x is a negative number. That makes x cubed to be a negative number and y square to be a positive number. That is a possibility. If x cube is a negative number, x being a negative number, x square is positive, y square is positive. The sum of those two numbers could be a 4, which is definitely possible. For those set of values, we can pick values such that x cube is negative. If x is negative, x cube is negative, y square is positive. The sum of these two will end up being a 0. So all conditions are satisfied only when x cube is negative. If x cube is negative, x is negative. The answer to a question is a definite yes. Combining the two statements without any ambiguity, we can come up with an answer that x is negative. Statements together are sufficient. Statements together are sufficient. Eliminate choice E. Choice C is the correct answer. Right. So this question, both eliminating A, D, B was relatively easy, but many times you might falter in this step when you're combining it, and fatigue sets in when you tend to combine the two statements. Persist there. Many a times it's also a test of endurance as much as a test of knowledge and intelligence. So more to the third question. It's a beautiful question. Again, it's a problem-solving question. Combines two concepts, linear equations and number properties. So at some level, we'll have to break this entire information given in the small CR kind of a passage into some mathematical expressions or equations, and then make use of some number property concepts to arrive at the answer. Start reading it. A movie hall sold tickets to one of its shows in two denominations, either a $11 ticket or a $7 ticket. A fourth of all those who bought a ticket also spent $4 each on refreshments at the movie hall. So there are some people who bought $11 tickets, some people who bought $7 tickets. Of all those who bought tickets, a fourth of them, 1/4 of them, spent $4 each on refreshments. The total collections from tickets and refreshments for the show was $124. What we need to find out is how many $7 tickets were sold. The number of $11 tickets sold is different from the number of $7 tickets sold. So it's saying take a variable x for it, for instance, and a variable y for it. X is not equal to y. Right? Number of tickets sold cannot be a negative number. That's also something that's evident. So we are talking about non-zero distinct integers for the values of the number of $11 and $7 tickets sold. Let's get started. I'm going to assign variables, as I said. Let's x be the number of $11 tickets sold and y be the number of $7 tickets sold. Then the total number of tickets sold is equal to x plus y. I'm going to pick this information. It says 124 was the total collections from tickets and refreshments. X $11 tickets were sold. So total collections from all X tickets would be 11X. Y $7 tickets were sold. So therefore, the total collections from selling all Y $7 tickets will be 7Y. Now comes to the refreshment. How much did they get from each one who bought refreshments? They got $4. How many refreshments did they sell? The total number of tickets sold divided by 4. A fourth of all those who bought a ticket also spent on refreshments. How many people bought tickets? X plus Y people bought tickets. A fourth of them spent money. How much? $4 on refreshments. So the total 124 collected is basically 11x plus 7y plus 4 times x plus y by 4. The 4 gets cancelled with 4. So equation basically boils down to 11x plus x, which is equal to 12x. 7y plus y, which is equal to 8y, which is equal to 124. And simplify this equation at this stage. Divide this entire equation by a 4. So we'll get 3x plus a 2y is equal to 31. So this is the equation we have landed right now. Let's land in this equation in a printed form, summarizing it, and then move on to finding out how many values exist. Right. So this is what we have. 124 is the total collection. 11x from $11 tickets, 7y from $7 tickets, and this amount from the refreshments, which gives us this equation that we saw in the last slide. Let's move on to finding out how many things are possible. We have x and y as distinct non-zero integers. We reduced this equation earlier on to make it as a 3x plus a 2y is equal to a 31. What is our objective? We need to find out how many $7 tickets were sold. So we need to find out what is the value of y. It appears as if you're going to get a single value for y. Look at it. We have one equation and two variables. All logic has told us if you want to find a unique solution, you need to have two equations, two variables. The only good thing is we know that there is a unique answer because thankfully in the 5 answer choices, they did not mention that the answer cannot be determined, because that would have been a temptation for us to go for that answer. Right? Make our life easy or make our life difficult. If cannot be determined is not an answer, you have to find an answer. If cannot be determined as an answer, you would have at least saved time and walked out and got the question incorrect. Let's see what happens here. Now I want the value for y. So let's rewrite this. 2y is equal to a 31 minus 3x. One thing that we know, x and y are integers. Now if for any integer y, 2y is going to be even. So the left hand side is even. That's established. That is a 31 minus 3x. 31 is an odd number. Unless you subtract another odd number from it, you are not going to end up with an answer which is going to be even. 3 is an odd number. If you want 3x to be odd, then you need to find out odd multiples of 3. What is the smallest odd multiple of 3? Which is 3. X can take a value of 1. So I'm going to list down values. I'm going to plug in values for x and correspondingly compute y. If x is a 1, then correspondingly 31 minus 3, 28 is the value for 2y. So y will be equal to 14. Can x be a 2? We want odd values for x. So let's quickly jump to 3 as a value for x. If x is a 3, 3 3s are 9. 31 minus 9 is a 22. So y becomes 11. If x is a 5, the next odd number, then we have 3 into 5, 15. 31 minus 15 is 16. Y is equal to 8. If this is a 7, this number is a 21. 31 minus 21 is a 10. This becomes a 5. If this number is a 9, 31 minus 27 is a 4. So y is equal to a 2. If I push this to 11, 31 minus 33, y becomes negative. So these are all the possible values for y. They've asked us for one value of y. I'm getting 1, 2, 3, 4, 5 values for y. How do I narrow it down to one single value? This is where this information comes in. They're saying a fourth of all those who bought a ticket spent money on refreshments. Number of people who bought refreshments is an integer. How many people totally bought tickets? X plus y people bought tickets, which means this value x plus y should necessarily be divisible by 4. Otherwise, we would not have had integer number of people buying refreshments. Is 1 plus 14 divisible by 4? No. 3 plus 11 is 11. 3 plus 11 is a 14, which is not divisible by 4. 5 plus 8 is a 13. This is not divisible by 4. 7 plus 5 is a 12. That's divisible by 4. 9 plus 2 is 11, which is not divisible by 4. So how many people bought $7 tickets? 5 people bought $7 tickets. So this question had two layers to it. One, framing this equation, which in itself took a lot of effort because we had to read through a lot of information to get there. Having got that, we were not left with two different equations. We were left with one single equation with some more information thrown in. From this, we had to narrow down this. Couple of pointers here which could save you time. Realize this. We know that this number is going to 2y is the coefficient of y is a 2. So the values of x are going to jump in steps of 2 because at the end of the day, this has to be a multiple of 2. Look at it. If I had written it in terms of 3, 3x would have been equal to 31 minus 2y. So 31 minus 2y should be a multiple of 3, which is why you see that the values of y come down in steps of 3. So if you see a 1 and 14, you write a 3, you can automatically say it's going to be 11. If it's a 5, subtract another 3 more from it. You needn't even calculate this as I did this way. So that's something that could have saved you probably 20-25 seconds. Quickly summarize all of this in a printed form. So that will be a beautiful way to recap this question. Divide this entire equation by 3, get a more meaningful equation. Now we have one equation and two variables. Let's plug in integer values to see what all will make sense. Here are all the values that will make sense. We need to zero down to which one of these will make sense. The thing that gives us the information as to which among these 5 values will work is basically that the number of tickets bought should be divisible by 4 because a fourth of the people bought refreshments. So which of these will work? Basically 7 plus 5 is the only one which is divisible by 4. Number of people who bought $7 tickets is 5 because that's what y corresponds to. Move on from here. The last question is a data sufficiency question on geometry. I just want to spend a minute here because a lot of people ask me, what are these member-only perks by joining this channel and how does one access these? Two things. You can join as a member for a small monthly fee, and for that you'll get some member-only perks. We keep adding and refining these member-only perks. To know what is the latest, click on the join button, which is on the home page of the channel or beneath any of our videos. We'll have a listing of the current perks that are available and also tell you what you need to pay on a monthly basis to access this. How do we communicate with our members? How do we share information with our members? We share information with our members through the community channel. Is this a different community channel than what we have for all of our subscribers? No, it's not a different community channel. The community tab is the same, except that if I post some of these messages for members only, that is not visible to the general subscribers. The members get to see the community posting that are posted only for members and for all subscribers. So members get both the postings. So any information, like the way we are running this member only monthly live session is posted. The link to this is posted in the community tab and it is made available only to the members. Some questions are posted which are available only to members. Early access videos are available only to members. So the means of communicating with members is through the community channel, where when we make a posting, we'll say that this posting is only for members. The others which we say for general subscribers is available to everyone. We'll move on to the last question. Relatively an easy question. Probably classify this one as a 650 level. The last three would have been 700 or 700 plus kind of a question. It's a triangle ABC, right angled at B, isosceles the question. Let's get started. What right isosceles triangle? Let's get an idea. It's a right triangle, one. It's an isosceles triangle. This is right angle here. I'll call it as A, B, C. Obviously, the hypotenuse is going to be the longer side. It cannot be the two equal sides. Isosceles triangles need to have two sides as equal. So this is side, let's say measures A. This side is going to measure A. So what is going to be the hypotenuse? Hypotenuse is going to be equal to A square plus A square under root of that, which is going to be equal to root 2A. So the angles of a right isosceles triangle will measure 45 degrees, 45 degrees, 90 degrees. Correspondingly, the sides opposite to them will be in the ratio of 1:1:root 2. Look at it, A, root 2A. So these are the basic information that we need to know about right isosceles triangles. Let's get started. Let's see from the information whether we can deduce that. Before we start any question, we're going to ask what kind of a question. This question is an is question. If you get a definite yes that this triangle is a right isosceles, data is sufficient. If you realize that it cannot be an isosceles triangle, then the data is sufficient. We'll say yes to this and we'll say data is sufficient. We'll say no to this and we'll say the answer is data is sufficient. Yes also means sufficient. A definite no also means sufficient. When is it not sufficient? when we say it may or may not be isosceles, I'm not sure, which is when the data is not sufficient. Dive into statement 1. All three sides are integers is what it says. The ratio of the sides of a right isosceles triangle we realized is 1:1 is to root 2. Let's just pick some example. Let's say this 1 is a 10, this is a 10. The third side is going to be a 10 root 2. Obviously, this is not an integer. Let's say this number is a 20. So if it is a root 2, this is going to be by root 2. So it's going to be a 20 by root 2. This will be a 20 by root 2. So these two will not be integers. If the ratio of the three sides are 1:1 is to root 2, at least one of these sides will not be an integer. This question mentions that all three sides are integers. Right isosceles triangle cannot have all three sides as integers. So we can conclude that the given triangle, this right triangle, is not a right isosceles triangle. So come up with a definite no as an answer. So statement 1 alone is sufficient. 1 alone is sufficient. We can narrow down our answer choices to A or D. Eliminate B, C, E. Quickly look at statement 2. The square of the hypotenuse is twice the product of the other two sides. Let's understand what this means. But before that, let's say the sides be x, y, and z is the hypotenuse. By Pythagoras theorem, we know that x square plus y square equals z square. That's Pythagoras theorem. Let's see what this statement says. The square of the hypotenuse is z square, is equal to twice of what? Twice of the product of the other two sides. What are the other two sides? X and y. So z square equals 2 times xy is what we have. You know, z square is x square plus y square from Pythagoras theorem. Plug that in here. So you'll get x square plus y square equals 2xy. Take all terms to one side. So you'll end up getting x square plus y square minus 2xy equals 0. It's nothing but x minus y, the whole square, equals 0. Translating to the fact that x minus y equals 0. X minus y equals 0. What does that mean? X equals y. If x equals y and these are the two perpendicular sides, what do we have? We have one side which is x. The second side is also x because x equals y. This obviously is a right isosceles triangle. From statement 2, we can give a definite yes as an answer. So if you are able to give definite yes as an answer, right, we'll just look at it. I've just come into this printed. We'll recap it and then go to that. Pythagoras theorem states x square plus y square equals z square if z is the hypotenuse of the three sides being x, y, and z. Now we'll decode the statement. Hypotenuse z square equals 2 times the product of the other two sides, which is what we get here. Replace the z square with x square plus y square and then solve for it. We get x equals y. If x equals y, we know that we are talking about a right isosceles triangle. Get a definite yes as an answer. Then we can eliminate answer option A because we're down to A or D. Now D is the correct answer to this question. Right? So this is an interesting question. Note one thing. Statement 1, what was the definite answer we got? We got an answer saying that no. Statement 2 gave us a definite yes. Did we still go with D as an answer? Certainly yes, because answer option D in GMAT essentially means that you need to answer this question conclusively with each of the statements. The answers need not match. More often than not, the answers will match. I just took pains to make these two statements such that they don't match, to highlight this idea that even if they don't match, the answer is still a D. Right? Because you get a definite no with statement 1, you got definite no with statement 1. You got a definite yes with statement 2, not by comparing them. Independently, you got that. So each statement was independently sufficient. Choice D is the answer. Right? So you guys, all of these questions have been posted on our question website called Q51.com. There are quite a few questions. We are trying to take this number of this must solve questions to about 50 in that channel. Right now, we have only 17 questions, including these. Over the months, next, I think probably if we had 4 a month, we have another 33 odd questions to do. 8-9 months, we should be reaching our target number. Right? Best wishes for your GMAT preparation.